Hello everyone. So welcome to our last problem of the string series. So which is minimum window substring. So this is a hard problem. That is why I kept it for last. Okay. So we will try to decode this problem for you so that you would understand it better. This video may be long, so follow along and we'll try to clear some concepts of you regarding this problem. Okay. And if you have not watched the previous string videos, I highly encourage you to watch those videos so that you will build the foundation on the string problems and then you can revisit here. Okay. So now this problem is called minimum window substring. Okay. And it is one of the common problem that is asked in the interview, not directly, but indirectly as well. Like it can be asked in different variation, but the logic, the concept is similar, which is being done in this question. Okay. So let's read through the problem. So given two strings S and T of length M and N respectively, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. Okay, so now we are given, so to gain the understanding of the question, so we are given two strings, S and T. Okay, and we need to return the minimum window substring. Substring, as you know, that it is a contiguous non-empty sequence of character, means uh, connected sequence of characters, like without missing any particular element. Okay. So now we have to return the minimum window substring such that every character, like all the characters of T are included in S. Okay. All the characters need to be included, including the duplicates as well. So, so like you can imagine like you are looking for the smallest piece of a book. Okay. String, consider it as a string S. Okay. That contains every letter from a shopping list. That is string T. Okay. Now, your goal is to find the shortest substring of the book that has all the items from the shopping list, exactly as specified. So you got the analogy, like what is asked. So, in clear words, so suppose we have this, like basically the substring must contain all characters of T, including duplicates. Suppose if T is equals to AAB. Suppose. Okay. I'll write it down for you. So suppose T equals AAB, suppose. Okay. So now the substring must have two A's and one B. And if there's no such substring, return an empty string. Right? Like in S, we need to have two A and one B. Okay. And it is written. Like there's only one unique solution for valid input. So don't worry about ties. Like you don't have to handle ties because it is mentioned that there is only one unique solution. Okay. Now, now what is happening is that so you have to calculate basically the minimum window substring. So suppose if you consider this example, okay. So now if you look here, so this particular portion, ADOBEC, so this contains all the characters of T, right? So this is a possible solution. This is a possible answer, but we need to return the minimum window. So we need to check for more options that can we have more substrings which can be minimum size like this. It has a size of 6, so can it be 5, can it be 4, can it be 3, right? So we need to keep track and we need to follow along. Okay, so in order to solve this approach, okay, we what we can do is we can follow a sliding window protocol, sliding window approach. So what sliding window approach does is basically we start from zero index. Okay, we start from zero index and we expand the right pointer to include more characters into the window. Okay. So, so firstly, what I'll do is, okay, firstly, I'll count how many times each character appears in T. Like how many times A is occurring, how many times B is occurring, how many times C is occurring. Okay. So this helps us to track what we are looking for in any substring of S, right? Because I have that count. So for that, I can use a map. Basically, map can easily store the count as a key value pair, right? And now I'll take 2 pointers left and right. Okay. I'll start both at beginning of S. Okay. Now I'll expand the right pointer to include more characters into the window. So basically treat it as a window. which I'll build and I'll shift the window. Okay. Now, and what I'll do is I'll shift the window to the right to include more character and contract the left pointer to shrink the window, right? Like if I have to increase the window size, I'll increment right. If I have to decrease the window, I'll decrement the left. So the window size will be decreased, right? Okay. And now I can keep track of the characters in the window and compare them with the shopping list, like as I was talking about, like consider it for shopping list. And basically the map, which is storing the values of t. Okay. And I can use a variable, basically I can take any variable to check if the window contains all the required character in the right frequency, right? And if that particular variable is equal to size of t map, so then that window is valid. Okay. So what I'll do is I'll just write it down some piece of code so that I can explain it to you better. Okay. Like what is the thought process behind it? So keep following along. Okay. So what I'll do is first step. First step, I need to store the let's start with the base case. Okay. So what if the string is null? Like what if s is null? Okay. Or what if t is null? In that case, I need to return only the empty string because that would be the minimum window because both are null. Or what if length of s is less than length of t? Then in that case, I cannot include all the characters of t in s, right? So then also I need to return an empty string only. Make sense? So if s dot length, I need to place an or in here, less than t dot length, right? So in that case, I would return an empty string. So first approach, like always write the base case. Like what are the possible edge cases, base cases that can happen. Okay, then only start writing the code. Okay, now as I was discussing that I need to store all the frequency, all the occurrences of the characters of t, so that when I'll check the string s, I would know how many characters, like which character is occurring how many times. Okay, so now for that I can take a map. Okay, so the key would be a character and the value would be an integer to store the count basically. Okay, so I can take it as a t count. Basically, I'm counting the frequency of t, so that name makes more sense. New hash map. All right. Now, I'll fill this hash map. So for character C and p dot to char array, because I need to fill every character. So I'm converting this particular string to a character array so that I can get character by character. Okay. So I'll now put this into the map. Tcount dot put. Now, if a value is already there, like if a is occurring twice, so I have to update its count to count by one, right? So I'll use tcount dot get or default. And I'll explain what does it mean. Okay. C comma 0 plus 1, right? So it's simple. Like if I would have done, I would have just placed the character C. And if it would have, suppose we have this string. Suppose we have t is equals to AAB. Okay. So at zero index, I put an A. Okay. Now suppose if I would have done tcount.put just the character and I encountered a second A. So then it would have put the value of, okay, C comma. I forgot to place it. So it would have put the value of, like, if I would have done C comma 0, it would have put the value in the map as A comma 0 only. But its count needs to be incremented because it's occurring one more time. So that's why I use this method. Like if that particular character is already there, then increase the count by one of its value, or by default take it as a 0. So you got about this method? Okay, I'll just drag it down. Okay. So now basically how the map would look like. So let's take the first example only. So I have T as ABC and SS. I'll just copy the string, right? Okay. So how will my map would look like? Like here, my T count map. How would it look like? Basically, it would have A as 1, B also as 1, and C also as 1. I'm writing comments in between so that you would understand the code. Okay. Make sure you follow along so that you won't miss any of the points. Okay. Now, I need to keep, like as I was talking about, like now I need variable so that I can iterate over string S. So I can take two variables. Okay. Int left equals to 0. Both will start from 0. Right also as 0. So both will start iterating S from 0. I would increase right so that I can increase my window. And whenever I'll get a valid window, I'll try to decrease left so that I can reduce the window size because that is what we want, right? Okay. And I'll take another variable formed. I can call it formed. So that will basically check uh like if that window, like the window we are trying to see, like if it is equal to the size of T's frequency map. Basically, formed is equal to the size of T's frequency map. So then we'll know that the window is valid. And every time we find a valid window, we try to shrink it by moving the left pointer to get the smallest possible substring, right? So I'll start both pointer from 0, left and right would start from 0. I would expand right and include characters into the window. Okay, so what I'll do is I'll add A. Okay, A will be added. Okay, then I'll add D, I'll add O, I'll add B, I'll add E. Okay, and I'll check if the valid window is found or not. So until here, until E, no valid window is found because not all characters of T are included, right? C is remaining. But once I add C, right? Once I'll add C, valid window is found, right? And that we'll know because we have the found variable. Okay. So now, since this is the valid window, so now I got a valid window. I can keep it as an answer, but I have to reduce the size. So in order to reduce the size, I need to move the left pointer. So I'll move my left pointer by 1. Okay. Now I'll check if the window is valid, but it becomes invalid because now if I move the window by 1, this will be my window now. So now it is missing an A. So now we'll try to increase it from the right so that I get an A. Okay. And then again, I'll keep it decreasing from the left. So if we'll continue this process, we'll get the string as our answer. Okay. So now I'll write the code so that you understand it better. So I have formed equal to 0. All right. Now, currently the minimum length of the window. So currently I can take minimum length as integer dot max value. Like I'll keep on updating it. Okay. So now, and I'm taking a integer array result. Okay. So that basically will help us like getting the result. Okay. So now result would be an array of three numbers that will be -1, 0, and 0. Basically, the format is like the format would be window length, left and right. I'll come back to this later so that you would know what is this. If you're not getting some part of it, don't worry. Just follow along. Okay. You'll understand the things. Okay. It's a hard problem. It's not an easy problem. It's not a medium problem. So it might be a bit tricky, but keep following along. Okay. Now, in order to keep track of the window, like I need to keep a track of the window size as well. So I need to take another map for the window count. What is the current window count? So I will take another map. Okay. So I can name it as window count so that it would make more sense and we would know why we have created this. Okay. Now, how many characters or how many elements do we require? Like we need three characters to be included in S. Those three are mandatory. So how can I take a note of the required characters? Like map dot size. So what is the map size for T? T count. tcount.size. So I can take it in the variable int. Example, the required size would be 3, right? Right? Makes sense. So we need 3 elements to be included. Okay. Now I'll start iterating for stringers. Now we have all the variables in place. Okay. So now while right is less than s dot length. So right would keep on iterating until we reach the end of the stringers. Okay. So now I'll take a character. I'll take the character because I'll need it later. So I'll store it in C variable. Okay. Now I need to update it into the window count, right? Because it is being added into my window. So I already have the map for that, right? So window count dot put character C, right? And if it is occurring multiple times, so again I'll use the get or default method. Okay. That if it is for the first time, it will take default value 0, else it will be increased by 1. Make sense? Now, now I have to see if the current character satisfy the t's requirement. Like if it is belonging to a value in t, right? So how will I check that? Like if t count, I'll check the t map basically. Okay. If that contains the key, so if that contains this character, which character? Character C. If it is containing this character, and and also basically the value is same, right? So basically the window count dot get this dot value. So its value should be same. The value should be same as the T map. Like it might be less than or less than that for now. So then we cannot include it, okay? But if it is same, then we know that we already got one character. Okay, so now A is 1. A is 1 in T. Okay. Now we got A here, and the integer value for both the map for A is equal. So it gets into this condition. So now we have the required character, that how many character do we want? And you remember we declared a variable formed, which will keep track of all the variable, like all the characters that needs to be included. So we found one character, so I'll increase the form, right? So we already got the character, so that's why I increased the form. Okay. Now, since I got this, okay, now I'll try to shrink the window. Okay. Like while left is less than equal to right. Okay. Until left is less. Until left is less. Okay. And like and formed is equal to required. Okay. So suppose when I'll get all of my characters. Okay. So until this point, what will happen? This loop will run. The right will keep on increasing. And when we'll get all the characters, when I'll get till this point, see. So I got all my characters. So at this point, formed will be equal to required. So then it will get into this condition, right? Makes sense? Because now we need 3 required characters and now found becomes 3. So we got a substring. We got one answer. Okay. So now if we got an answer, so what we have to do, we have to shrink the window to see if there's a smaller window possibility, right? So how will I shrink the window? By moving left. So I'll keep a note of, I'll basically update the character. I'll update the current character. So I'll take the left character. Okay. Now, if if right minus, basically I need to check if it is less than the minimum length, the current window. So if right minus left plus 1, it's less than minimum length. So what is the minimum length for now? It is the maximum value. So obviously this window would be like checking if current window is smaller, right? So it is smaller. So then I would update the minimum length. So minimum length would be right minus left plus 1. Makes sense? Okay. Now, so as I took a result array, right? So it is storing window length, left and right pointer. So I'll update the result array. So result of 0 would be minimum length. Since it is updated, result of 1 would become, so what it is storing, left. So it will be left, and result of 2 will be equal to right. Because we'll need this value, like if this is the minimum window, okay. And now, since we are now decreasing the window size, okay. So if we are decreasing the window size, we have to remove the leftmost character, okay. So what we'll do is, we will remove the leftmost character, okay. Now, how will I remove that? So I have to remove it from the map. So what is our current map? That is window count. So window count dot put. Okay. Current character, that is in left character. Okay. C, comma, window count dot get. It is obviously there in the map, so get will work. -1. So I have updated its value by -1. So now I have decreased it. Okay. So if it is 1, it will be 0, right? So now it's removed from the map. Okay. Now if the T map, basically the T count, contains this key and the value is say is less than the current value, so then I would reduce the found. So basically what I am doing is, if T count dot contains key, if this value was there in a T, okay, T map, like if it is the required value, okay, and window count dot get C dot int value, right? If it is less than the value in T count, like if it is less, like if the value becomes less, means we have removed a required character, which was not, which was the part of the valid window, like in this case. So if we have removed the leftmost character by after finding a valid string, so I removed A now. So this is my substring. So this is a valid character now. So this becomes an invalid string now. Okay. So that's why I'm checking this condition. Okay. So if it is less than T count dot get C dot int value, okay. So I know now that a required character has been removed. So in this case, formed will be minus minus because a required character is removed, right? And I have increased my left because now I'm shrinking the window, okay. And right would also be increased because now I have to find a valid window. So for that, I need to increase my right as well because this window becomes invalid now, right? So now I'll get out of this condition. So now I'm out of the while loop. Okay, now this is working fine. So now I would return my answer. So I would return like if result of 0. Okay, so if result of 0 would be -1, like I haven't got any minimum window. Okay, so if it is negative, then I would return an empty string, right? If it is not, then I would return a dot substring. What will be my substring? It will be left and right. But left and right, where it is stored in the result. Result 1 index and 2 index. So I would call it from there. So it is upper bound exclusive. So I would add +1 to it. Okay. So this will give me my result. And now I believe this code should work. Okay. Then if it works fine, then we'll discuss the time complexity and I'll try run the code for you so that you can understand it more better. Okay. So So I'll quickly submit this code. All right. So it's working as expected. Don't worry about the complexity. Okay. So now, firstly, let's discuss the time complexity of the code. Okay. So now we know that here our loop is starting. Okay. And right pointer is iterating over the string s once. Okay. And the left pointer also iterates over this string to shrink the window, right? Like here, we are shrinking the window. So it is also moving once. Okay. So now, in total, the two pointers combined traverse each character of S at most twice. Okay, at most twice. So the time complexity would be big of M, where M would be length of S, right? M would be the length of S, as it is mentioned in the question. Okay. And for hash map operation. Okay. So that's a good thing about hash map, that accessing and updating values in the frequency map, okay, or hash map for S and take T will take only big of one time on average for each operation because there are a fixed number of unique characters, right? And fixed number of ASCII or Unicode. So thus the overall time complexity would be big O of m plus n, where m would be length of s, n would be length of t. So the time complexity would be big O of m plus n. Okay. Now what will be the space complexity? So now we have taken frequency maps. So that would have taken some sort. So t or t map, this t count. The size is proportional to the number of unique characters in T. And okay, and the second map is we have took window count. Okay, so these keep track of the character in the current window. Okay, so what will be the overall space? So it will be proportional to the number of unique character in T or 26 if only we are using lowercase English character. So the overall time complexity would be big of k, where k would be the number of unique characters in T, right? Right? Makes sense. So big of k would be the space complexity of it. Okay. So now, since you got the code, since you got the idea, I know it might be a bit difficult. Let's try run it in a fast way so that you would understand some part of it. Okay. So this is our T, this is our S. Okay. Initially, this is our map, right? Formed is 0, required would be what will be required? So initially, okay, required would be 3, right? Okay. And so now right pointer will move. Okay. So now window count will become a window count map would become A1. Informed will be 1 because we have a valid A. Then we'll add D. Okay. So window count will be A1, T1, right? Found will be 1 only because we found only one character. Okay. So until I get a C, it will put all the value in the window map. And now the found will become 3. That means a valid window is found. Okay. When I have found a valid window, I'll try to reduce the size by incrementing left pointer. If that left contains a valid string, then again I will increase my right, okay, and start comparing the string from this portion until I get a valid string. Then again I'll try to shrink the window. So this way, you got it. Like we'll reach to the solution. I know that this code might be very intimidating, but once you like the concept is very easy. I know the code might become very tedious, but you understand the logic. Don't worry about it if you need to see the code and write the code. That is also fine because the important thing is you need to understand the concept, and it's a hard question. So it is not an expectation that you would know this question earlier, but I made this long video so that you would know how hard problems will look like. Okay, so I hope you got some idea with this. I know I went too fast, but we will cover some more problems and I'll start another data structure series. Okay, so now I'll see you there. Until then, goodbye.